hardly any neuron that only receives input from one other neuron. Most neurons receive input from hundreds of other neurons. Some of the hundreds of neurons are excitatory. They're releasing chemical transmitters onto our neuron of interest that say, yeah, go ahead and fire off. But at the same time, there might be a number of neurons that's trying to influence the same neuron not to fire. They do that by releasing inhibitory neurotransmitters. So at any given instance, you might have a certain amount of excitatory and a certain amount of inhibitory neurotransmitters. And their effects will have to add together to determine whether or not the action potential can be reached.
Is that similar to that whole like fight or flight theory?
Fight or flight is going to come into it on a larger level when we talk about the sympathetic and parasympathetic nerves. But what all nerves are doing is this, either firing or not. That's all a nerve can do, okay? And so for a typical nerve, what determines whether or not it will fire off will be the added results of many presynaptic neurons. In mathematics, what do you call the answer when you add things together?
Sum.
The sum. And this process of adding together the effects of many neurons at once is called summation. Okay? And we will later find that there are two ways in which you could have an added result. It's called spatial summation and temporal summation. But we're working our way to that. Okay. So that's giving you the overall picture. So now let's start to deal with details to explain the graded potentials. What happens in the graded potential? What happens in the action potential? Which is really what we want to get at. Okay?